Alright, we are on the second video of the first page of Semester 1 Final Exam Review. And here we are going to write the solution in interval notation. So I'm going to do each part of this. X greater than 8 would be parenthesis to infinity. X less than 5 would be 5 from negative infinity to 5. Since the two are separate groups, we would union them. For the second one here, we're going to graph it to show. Here we have x is greater than 5, that would be a parenthesis going that way, and x is greater than 8 would be a parenthesis going that way. Since it's an and statement, it has to be true of both of them. It starts to be true of both of them at the 8 and goes to positive infinity. In question 9, we're going to do the same graphing thing. Here we have x is greater than 8, so that'd be a parenthesis going to the right. X is greater than 5, parenthesis going to the right. In this case, it's an or statement, so it only has to be true of one of them. It starts to be true of one of them at the 5 and goes to infinity. For question number 10, we have a compound inequality, so I'm going to add 1 to all three parts. I get 7 is less than or equal to 3x is less than to 12. Then I'm going to divide all three parts by 3, leaving me with 7/3 is less than or equal to x is less than 4. Again, we're supposed to be putting this in interval notation, so I'm going to write from inclusive 7/3 to exclusive 4. Here we have a absolute value. I'm going to split it into its two equations, inequalities. I get x plus 1 is greater than 18, and my other one would be where the thing in the absolute value is negative. Solving, I get x is greater than 17, and over here I can distribute the negative, giving me negative x minus 1 is greater than 18. Adding 1, I get negative x is greater than 19. And then multiplying the whole equation by negative 1, I get x is less than negative 19. In interval notation, that would be from, since x is less than negative 19, it's going from negative infinity to negative 19. And x greater than 17 would be from 17 to positive infinity. Since they are no overlap there, we would union them, and it is an or statement because of the greater than. In number 12, we're going to split it. We're going to have 2x minus 5 is less than or equal to 25, and negative 2x minus 5 is less than or equal to 25. Solving, I get 2x is less than or equal to 30, x is less than or equal to 15, and again, this is an and statement because of the less than. Distributing my negative, I get a negative 2x plus 5 is less than or equal to 25. Subtracting 5 from both sides gives me 20. Dividing by negative 2, remember to switch the signs when you divide by a negative. And there's my two solutions. Since we're putting them in interval notation, x is less than or equal to 15 would look like that. X is greater than or equal to negative 10 would look like that. Since it's an and statement, we would write it as inclusive negative 10 to inclusive 15. For question number 13, we're solving for w, so I'm going to divide by L, divide by L. I get w equals a divided by L. For number 14, we're solving for L, so the first thing I'm going to do is subtract 2w from both sides. I get p minus 2w equals 2L, dividing by 2, dividing by 2. I get L equals p minus 2w over 2. For question 15, we're supposed to solve the system of equations by using substitution or elimination. Since y is already solved for, I'm going to use substitution. I get 2x plus 5 times the quantity of 2x plus 9 because the y is equal to that. And that's equal to 57. Simplifying, I get 10x plus 45. Putting like terms together, subtracting the 45, I get 12x equals 12, so x equals 1. We need to substitute that back into one of the original equations to get the y value. If I plug it into here, I get y equals 2 times 1 plus 9, or y equals 11. In this one here, I'm going to use elimination because I have a positive 3x and a negative 3x. When I add them together, the x's go away, and I get 16y equals 48. Dividing, I get y equals 3. Again, I want to substitute that back into one of the original equations, giving me 3x plus 5 times 3, that's y, equals 21. Simplifying, 3x plus 15 equals 21, minus 15 minus 15, I get 3x equals 6, so the x must be 2. So the point I get here is 2, 3. Over here, my point would be 1, 11. For this number 17, we have the cost and the revenue functions, and we want to find out when they're equal to each other. Well, when they're equal to each other, the 200x plus 6,000 will be equal to the 500x. Subtracting 200x from both sides, I get 6,000 equals 300x. Dividing by 300, I get x equals 20.